In this video, we're going to create a sloped and mitered concrete head wall, which is kind of like an apron on top of a pipe as it exposes past a slope. And the first thing that I did before recording was I created a bunch of variables that kind of matched the detail that you see on the left. We have a slope x to 1, a variable for a, b, and w, and I'll be adding other variables later, but I'm just creating a couple of variations that match so I can test things as I go along that kind of fit what we're trying to hope for. So we have a 3-to-1 slope category, 4-to-1 slope, and a 6-to-1 slope category. I have two 3-to-1s for 15-inch and 18-inch, two 4-to-1s for 15-inch and 18-inch, and then a 6-to-1 for 30-inch. So the first thing I'm going to do is I'm going to create the side profile because I want to define the slope. And so I'm going to go to my right view, and I'm pretty much just going to draw a triangle that represents a slope. We could do this any number of ways. We could do this with degrees, but 4-to-1 slope is how we're kind of used to looking at this. So I typically would just draw a bunch of these types of construction lines. I want to place my shape at origin 0, 0. That's just a practice that I've had for many years. And I want to make sure that these two pieces are parallel. And so if you can guess, one side's going to be equal to 1, and the bottom is going to be equal to x slope, so 4-to-1, 5-to-1, 3-to-1, and this slope matches the hypotenuse matches the slope that I want. And I'm fixing, I did a fixed constraint to the 0, 0 point, because I don't want it to move anymore. This is how I want everything to expand. So we're going to create the top, I guess, panels or the top concrete aprons. And it's defined by two variables of width of W, and the height of it or the length of it would be A and B. And that changes per variation. And so I have a 5.5-inch thickness. I did an auto constraint because I want them to both be parallel and perpendicular. And I can quickly copy and paste. So I can change one from B to A variable. And as you see, as I change variation, all of those pieces moved and changed. So I kind of want both of these to be always parallel to that slope. So if my slope changes from 3-to-1 to 4-to-1, they'll move the same. So I change them to be parallel. And since we're all drawing in the same plane, everything is going to be usable by the 2D point for now. And I constrained both of those with a coincident, the A and B slabs together. And I also use the coincident to tie slope or slab B to the triangle that I drew. Now I'm going to draw the little toe. And the toe is defined by 1.5 feet deep and 8 inches thick. I'll use my auto constraint to make sure that it doesn't turn into a parallelogram. And I'll constrain that as well. So now I have my side profile, and I'm pretty much ready to extrude. So I'm going to rotate the view. I'll turn off my constraints or my geometric constraint view just so I can kind of look at it, and I'll hit extrude. And I'll choose the distance W to make sure that it's parametric. Now for now, I'm keeping them separate. Later on in the video, we'll talk about how we can unite them, and there's kind of a little bug and some things to watch out for. So luckily enough, this is all just going to be straight extrusion of that W value. Now, I want to change this class to construction because I don't really need it anymore, or I mean, I need it there, but I don't need to always view it, and I'm afraid of accidentally cutting through it or messing with it, so I change it to construction class and turn construction classes off. And as always, test your variations, test your variables to make sure that it behaves and moves like you want to. And now I want to focus on creating that center pipe piece. And I'm creating, I need to figure out a way to make sure that my pipe is coming out of the middle of that B slab. So in my variables, I created a B divided by 2. I don't need a W divided by 2, but I do need a B divided by 2 and a pipe diameter because my different variables for pipe diameters or pipe radii will determine the different pipe sizes and the different slab sizes. So I deleted out the W2. And since I'm not used to looking at things from either the pipe diameter or maybe I'm used to looking at it from the radius because I create a circle. Usually I define that circle in MicroStation through a pipe radius. Adding the variations for the pipe diameter. So this is just one of those things that the detail might work a little bit differently than the way that MicroStation or OpenRoads would work. So I want my input to be the pipe diameter, but my MicroStation is going to be using the pipe radius. And so I created an expression called pipe diameter divided by 2. So now I'm going to create a bunch of these little like construction lines to make sure that I'm always kind of grabbing the middle of that slab. And in 3 dimensions, the coincident constraint doesn't work with midpoints the way that 2D constraints work. So we're going to do the 2D constraint for this one particular 2-dimensional piece to make sure that it's on the same plane as some of the other pieces in that B value. And I'm assigning them B divided by 2. So I have one length of piece that's always going to be in the middle of that, or B divided by 2, really. It's going to be the distance of B divided by 2, which would represent the middle. But something looks a little bit off. So here, when I change the variation, the angle of that middle line stayed the same because I didn't constrain it enough. Now, you don't always have to constrain everything to the perfect amount of degrees of freedom, but just enough to get you what you need for your variables. So what I like to do is, in this particular position, I'd want to make sure that it's parallel. And that kind of gets me what I want. Since it's on the same plane, it's not kind of going deeper or above the slab, and it's not coming in at a skew because it's always going to be parallel. So I test it. Looks good. Now I'm going to go to my front view because I want my pipe to be straight. In this particular case, my pipe is going to be straight. May not always be the case in real life. But I'm going to draw a helper line to represent the height of where I need this pipe to come in. And so I drew a circle in that front view, and I'm going to assign it the pipe radius. Now remember, my pipe radius is an expression of my pipe diameter, which is the input. And I drew it on that front face. So it's kind of planar to that front face of that cell. And since that same line is drawn up straight, I want to make sure that it's always the same. Kind of like that center line is going to be constrained to the slope line that we created, the parallel slope line we created. And so that circle will be constrained using the concentric 3-dimensional constraint to that one line. And then I'm going to use the 3-dimensional coincident for that vertical line to tie to that middle. And so as you see, when I change this variation, the radius, that circle, moves up and down. Now the last step is I'm going to use the cut command for this circle to cut through the pipe, for the circle to cut through the slab. So I can see it easier. I'm going to change it to transparent view. And my profile, I want to keep it because I need to cut it multiple times. So I'm going to keep it as show, but on the second one, I'm going to going to cut it and make sure that it's hidden. And then I'll change these back to construction. So here is my slab, my head wall. I'm going to go through and change things. It's pretty much ready to use, but for one reason or another, I may want to merge them all together as one slab, just for a cleaner look or something. So I'll use that unite, and I'll start uniting all of them together. Now, I mentioned earlier that there's kind of a bug. So once I united all of them together, I do want to go through all the different variations, and you'll see when I zoom out here that some of the W values hadn't worked. So what I can do is click on that one piece in the properties dialog box or properties pane. I can navigate down to the parametric solid, and it's a static 5.25. I can go back in, change the distance to the W variable. It's probably worth checking some of the other different variables as well to make sure that it applied appropriately, but it seemed to work for what we need. And now it's ready to be used in the parametric tool to propagate them to multiple different cells using the VBA.